Hello everyone, this is Dr. N.G. Pravina, working as Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. In this video lecture, I am going to tell about the addressing modes of 8086. What are the topics you are going to learn through this video lecture? Why to study the addressing modes, and what are the types of addressing modes we have in 8086. So these two topics we are going to study in this lecture. Why we have to go for this addressing mode? Very simple. When 8086 executes an instruction, it should understand the operand type and the type of the data which has to be accessed. For doing this, we have to follow some addressing modes. Basically, the addressing modes are classified on data, program memory, and stack memory. The types of the addressing modes that are used in 8086 are listed here: immediate, direct, register, register indirect, indexed, register relative, base, index, relative, based, indexed. We'll discuss the addressing modes one by one. First addressing mode we are going to discuss is about the immediate addressing mode. As the name itself implies, here the data will be a part of the instruction. So the data will be a part of the instruction. It will be available as byte or bytes in the instruction. For example, move AX, 10ABH, whereas move is nothing but a mnemonic, where AX is nothing but a general purpose register, whereas 10AB is nothing but an immediate data. So the type of the addressing mode is said to be immediate, since the data is available here in the instruction itself. So before executing this instruction, where the content of AX has been taken as FF and BC, when this instruction has been executed, the processor will replace the contents of AX with the data available in the instruction. So AL will be taken as AB, whereas the content of AH is replaced by 10. The second addressing mode what we are going to discuss is about the direct addressing mode. In this addressing mode, a 16-bit memory address is specified directly in the instruction. For example, move AX, 5000H. It is represented within a bracket. It is not a data, whereas it is a memory location. So when you execute this instruction, the data which is available in 5000 has been taken into AX register. Assume the content of AX is FFBC. When this instruction is executed, it moves to this memory location 5000. In 5000 you have a data 22. So the 22 will be taken into an AL register. The memory will be incremented by 1, and the data available in 5001 is 33, and the 33 is replaced in the AH register. The third addressing mode we are going to discuss is about the register addressing mode. Here the data will be directly stored in the register. It may be an 8-bit register or a 16-bit register. All the registers can be used in this type of addressing mode, but the instruction pointer we cannot use it, because you know that is meant for pointing the instructions. So for example, I have given here move AX, BX. Here the content of the BX register has been given to a AX register. Here AX is the destination register, whereas a BX is the source register. Assume the content of the AX is FF33, whereas the content of the BX is 10AB. When this instruction is executed, move AX, BX, the content of BX has been given to a AX register. So AX has been replaced by the content of a BX register. So this is the way this type of addressing mode will work. The next addressing mode we are going to discuss is register indirect addressing mode. As the name itself implies, here the indirect addressing has been used. The memory of the data has been stored in the register. For example, move AX comma BX, it has been represented within a bracket. So BX will not hold the data here, instead it will hold the memory location. Here AX data has been taken as FF and AB, whereas BX data is 5000, which is nothing but a memory location. When you use this type of addressing mode, the content of BX has been considered and the pointer will move to this memory location. In that location you have a data 22, it will be taken into an AL register. The memory will be moved to the next location. The 33 will be moved to an AH register. The next addressing mode what we are discussing is about the indexed addressing mode. In indexed addressing mode, the operand offset is stored in the index registers. As we know that we have two index register, one is the source index register, the other one is the destination index register. And to calculate the physical address, here the default segment what we use is a data segment, it's nothing but a DS. Example, move AX comma SI, it is represented in a bracket. Here assume the AX data is FFAB, whereas source index holds the memory location 5000. When you use this addressing mode, the processor will move to this location 5000. The data which is available here is 22, it will be given to a AL register. The memory will be incremented by 1 and the 33 will be stored in the AH register. The next addressing mode is register relative addressing mode. In this addressing mode, the effective address is calculated by adding two components. One is the 8-bit or 16-bit displacement and the other one is the content of the registers. It may be a base registers or it may be a index registers. Example, move AX comma 50H BX, where 50H is the displacement and BX is nothing but the register. Here assume the content of AX is FFAB and the content of BX is nothing but a memory location, it is 5000 and the offset displacement is 50. So 5000 is added with 50 and the memory location is 5050. So the pointer will move to this memory location 5050. The data which is available here is 22. It will be stored in the AL register. It will be incremented by 1 and the next data will be stored in the AH register. The next addressing mode is based indexed addressing mode. Here the effective address is calculated by adding the content of the base register and the index register. Here data segment is taken as a default segment. The base registers are nothing but BX, a general purpose register, and BP, a base pointer register. And the index registers are nothing but we have two index registers. One is a source index register, the other one is the destination index register. So as an example, move AX comma BX SI. Here the content of AX is FFAB. The memory location has been obtained by adding the content of BX and SI. Assume BX is 5000 and the content of SI is 2000. Both the memory location has been added and a new memory location has been taken as 7000. The pointer will move to this memory address. The data available in this address is 22. It is moved to the AL register. The memory will be incremented by 1 and the data available in that next location will be stored in the AH register. The next addressing mode is relative based indexed addressing mode. Here the effective address is calculated by adding three components. One is the 8-bit or 16-bit displacement, followed by the content of base register and followed by the content of the index register in with data segment as a default segment. Assume the content of AX is FFAB. The new effective address is calculated by adding the displacement value 50 with the content of BX register and the content of the SI register. So the memory location is 7050. The pointer will move to this memory location 7050. The data available here is 22. It will be stored in the AL register and the memory location will be incremented by 1 7051 and the data is 33. It will be stored in the AH register. So hope this video helped you to understand the types of the addressing modes that we use in 8086. Thank you all.